So let's have a look at some public works infrastructure. Okay, the infrastructure in a city, let's look at 4 of the main systems: road and storm drain, water and sewer. So let's have a look at the map that's in one of the first pages of your packet. I've got it on page 3. So it's around there. So what we have here is just a real simple sketch of a city. It's on a river there. You see the flow of the river to the left or the west. We have a stream coming in. We've got some hills running east-west through the city there. So we've got those. It looks like we've got north going that way, of course, and then we'd have east and west and south. Okay, something like that. So we've got the hills running east-west through the city. We've got some streets and buildings to the north of the hills and some streets and buildings to the south. So let's start at looking at the roads. Okay, so what we have here to the north, which I've circled in red, we've got street with curb and gutter. To the south, we have streets with no curb and gutter. Okay, I've also got the grade of the roads shown with arrows, so you can kind of see, by the grade I mean the slope. So you get an idea, as you would expect, the ground is sloping down towards the river, and on this side it's sloping towards the stream. So that gives you an indication of the direction that water would move across the road. All right, now the curb and gutter is significant. It does affect the design of the roads. So on the north we've got curb and gutter, as you would see here in this sketch. To the south we have no curb and gutter, which was more like this sketch over on the right. So when we have curb and gutter, what we have is a gutter system. What we'd like to do with those roads there is to sink them into the surrounding area. That way the runoff will come off of these lots and get into the gutter. Once it's into the gutter, we can then slope the gutter into these little what are called catch basins or curb inlets here, and then get the water into pipes so we can carry it away to what we call the receiving streams, in this case the stream or the river. So the approach on this again is to design these roads down into the ground a little bit so that the gutter will serve as a drainage conduit for the surrounding area. All right, now if I don't have, so that's what we have here on the north side. On the south side, we don't have curb and gutter, so the assumption there is we have a road with a ditch in it. In some fashion, you have to take care of the drainage water when you build a road. So here we're doing it with a ditch. So the approach here is going to be to build the road up and out of the surrounding ground and then have ditches on the side that carry the drainage water. So what's going to happen here is when the water runs off the road or comes in from the surrounding area there, it's going to get into the ditch. And then we'll have things called culverts that get the road across driveways and street crossings and things like that. You can also see here that not only does the runoff water come into this ditch, but it brings a lot of stuff in with it. Now this road, what it's composed of is compacted gravel underneath. The normal soil in this area would not be strong enough to support a road. So it's excavated and taken out, and then we bring in gravel that's well compacted and strong. Then we put a driving surface on top, generally either concrete or asphalt. Okay, so this road carries the traffic, of course, but then another very important consideration with it is the drainage, which can be handled in either of these two ways. All right, so the storm drainage and the road, those two systems are linked together. So you do have to consider how the water will flow across the road and then design a drainage system to accommodate that. You don't want, you've got to have some system to get the water off of the road. That's the idea. Also, when you start building these roads without curb and gutter, they typically serve as dams and kind of run across the ground and can back water up behind them. Even a curb and gutter road can do that in many cases, but it certainly is the case with a non-curb and gutter road, is that you get that kind of blocking the flow of water, so you have to account for that. All right, so let's have a look at the storm drainage here for this drainage pattern that I'm showing. All right, now on the top part of the the road system here, the north side, what we have is curb and gutter. So what we're going to have are things called curb inlets, or perhaps we might have a similar thing called a catch basin. Anytime we kind of create a corner where the water is going to collect, or at a certain given distance along the road, we have to put these in to get the water out of the gutter. So these are just boxes. They're graded boxes, and the water flows into them. You can see one right there in this circle here. So I start with those. So anytime I've got like a corner here, like this would be a good example, and this corner right up here, I've got the water flowing north and the water flowing west. Well, on this corner right here, the southeast corner, the water's just going to sit there unless I do something about it. So I would put a curb inlet there to pick up the drainage out of the gutter. And I've got curb inlets at a lot of these intersections. That's typically where they're at. But they might also be on a long straight run of road, because you don't want to make the gutter carry the entire flow. Every now and again, you want to put these curb inlets in, or catch basins. So I've got those designated with boxes that are colored in purple. Okay, from there the water will flow to a manhole. Okay, so you'll take the water from the curb inlet, run it into a manhole with a section of pipe, and then the manhole will then run the water into a pipe, and then the pipes will be directed to the river or stream. Now, in the old days, that was pretty much it. Okay, that's what you did. You just took the water off the road and ran it into a river or stream. Nowadays, though, we're much more concerned about treating the water. We don't just want to take it right off the road and put it into a river or stream or lake or pond or whatever. So we have some treatment methods now. We use oil and grease traps, sedimentation basins, bioswales, detention ponds, sand filters, things like that, that help to treat the water before we discharge it. Okay. Now on the south side here, we've got this high non-curbed road. So what we're going to have are ditches all the way around it. Now you can see here on this inside, we might get the water to flow around there, but at some point we're going to have to put a culvert, which is a pipe under the road, to get the water from the inside of this road across to the other side so that it can then flow into the stream. So I probably need a culvert, as I've shown, in all these places where this road would serve to dam the drainage water up. So that's where I have culverts. Now culverts are just pipes that go under a road or driveway that allow the water to pass underneath. So that's what I'm doing there. Okay. All right, so there's a picture then of some of these things we're talking about. What we have here is a culvert right there. Here's a manhole sticking up out of the ground. Now, they're not usually sticking up out of the ground. Usually, of course, they're down flush with the street. What you'll see in the street are these lids. And then here we have this particular one is a catch basin where I have a grate there that will lead the water down in to this box. That's a concrete box there, and there's a pipe running out of the box that would then go to the manhole. Catch basin has a grate on the level of the gutter, a curb inlet. The water enters in through the curb. So this one's kind of a combination, catch basin and curb inlet from the look of it. Okay. All right, so that's the basic system for the road and storm drainage. Now we also have to provide all these homes and businesses and factories or whatever they are with water as well. So that requires another system. Now the water plant is where you treat the water. That will usually be on the, or most always be on the upstream side if you're on a river. So you want to get that water in its cleanest condition possible, which would be upstream of your town. So that'll be on the upstream side of town. You then have a plant. Now you might also have wells. There's different ways of getting water. You can get surface water, in which you'd have a water treatment plant. If you have wells, you may not have quite a real fancy plant, but at some place you need a source of water. From there you pipe it to all the different buildings that need water. So what you do is you create a system of pipes running through, usually somewhere near the road, typically under the road, then they might be next to the road, it just depends on the city. Typically when you're putting these pipes in, you loop them. So you connect them all together into a network. That leads to more efficient hydraulic flow to get the water where you want it to go. So that's why I've got all these pipes kind of running in a network, in a looped network. I do have some dead end lines when I've got a dead end street. Okay, I'm going to go up and over these hills. So I might have a storage tank in the hills. That would be a convenient place to put a storage tank, as that will store pressure. So that might be a good place for that. And then I've got the water system on the south side too. All right, now when I put those pipes in there, I need to put valves in. These are typically just on-off valves. So they're gate valves, typically shown with that bow tie sort of symbol. What I like to do when I have intersections is be able to control the intersection, so I can shut off different branches of the system. That way, if I need to work on it or if I have some sort of problem, I don't have to shut the whole system down. I can just shut those valves and then reach that part of the piping system that needs repair or needs some sort of maintenance. Okay, so the valves are typically on-off valves. They're gate valves. They give me control over the system. Okay. So I've got those valves shown. Typically, if you have an intersection, you'll have one less valve than you do branches coming into the intersection. That gives you enough control. So here's a four-way intersection, for instance. So what I've got here are 3 valves. I can shut any of those branches down that I want using those 3 valves. Here's a 3-way intersection, so 2 valves is typically enough. Valves are expensive, so we don't like to use them any more than we need to, but of course you want enough valves to be able to control the system. I also would probably have some sort of pumping station at the water plant too to get the water running through the system. All right. Now, in addition to this, I would also want to put fire hydrants in too. So I've got fire hydrants shown here. Typically, they're every so many feet, 300 feet or so. The firefighting department needs access so they can get their hoses hooked up and fight fires where they need to do that. So I've got fire hydrants spaced throughout this area, and hopefully they're close enough to all the buildings so that a pumper truck could attach a hose and then use those fire hydrants to fight fires anywhere that's needed in town. They also serve as places where you can flush the line out and clean it too, so they're kind of your entry ports into the system. All right, so there's a storage tank. We like to store the water nice and high, so that way it stores pressure, and you can use it to pressurize your system. If you have some hills, that's a good place to put a tank. That's a nice high place to put it. Fire hydrant, of course. Here's some different pipe fittings that go in to connect the pipes together over here. And then this is a water service. I didn't show that on my map because it would get so cluttered, but we have small pipes that come out of the main. So this is the water main, typically 8 inches or somewhere around there in size. Then we can run a smaller, maybe 1-inch line off to feed each of the homes. So this would be done here. This is the start of a water service that taps into the main and gets the water to the homes. All right, the next step here, if you're taking water to all these homes and buildings and manufacturing plants and whatever sort of buildings these are, we would also have wastewater that we have to deliver and put back in the river. Okay, so that's another system. All right, so typically we're going to have a wastewater plant that treats this contaminated water before it's discharged into the river. Now, typically that'll go on the downstream side of the river, okay? So your water plant is up here where the water's clean, the water's flowing this way, so the wastewater plant is on the downstream side. Now, that's done for a couple of reasons. One reason is the sewer system that takes the water to the plant flows as much by gravity as possible. So you want the plant on the low side of your town. That way the wastewater will flow by gravity to get there. And the other reason, though, is that you want your wastewater plant downstream of your water plant because you don't want the wastewater discharge going into the water plant. So that's the other reason. So what you're going to do then is create a series of manholes that connect pipes together. The pipes have to access all of the buildings. The buildings will have what are called services, which are small, maybe 4-inch diameter pipes that go out and then feed water into the larger sewer mains. Anytime you have an intersection or a change in direction, And also about every 300 feet, you want to have a manhole, which allows maintenance of the sewer mains. Okay, so what we have then are the sewer lines branching through the city. Notice they don't have to be looped like the water system does. All we got to do is slope these downhill so the water flows. We don't need to loop them. They're not pressurized like a water system, so there's no need to create an efficiently looped hydraulic system with them. And we just connect these pipes together and they lead down to the wastewater plant. Typically, of course, as they get closer and closer to the wastewater plant, they get bigger and bigger, okay, because you get more and more flow in them. Now, what we have here is one situation here where we have this the line of hills running through the city. That's going to create a high ground that's going to make it really hard to dig deep enough to get that pipe flowing by gravity downhill to where you want it to go. Okay, so we can't get the water up and over those hills without putting in what we call a lift station or a pumping station right there. So this manhole right here would very likely be turned into a pumping station. So there would be a pump there that would have then a pressurized main called a force main that would then push that water uphill to a manhole at the top of the hills. From there it would flow by gravity down. So that's a feature on the sanitary sewer system that you often have, or lift stations. Even if you're in flat ground, if you run a sewer main for a long distance, it's going to have to slope down, so it's going to end up getting deeper and deeper and deeper. And somewhere around 15 or 20 feet of bury, it's just too tough to maintain something like that, so you'll put a lift station in there to lift the wastewater back up to a more reasonable depth of bury on the pipes. Okay, so again, there's a manhole, and then there's pipes that run between the manholes. Okay, so those two maps there are in your book, and we've kind of run through those. Let's have a look then at how we draw these systems up. And I've got a description of that in your book, and then I get to some plan and profile there. Currently, that's page 10 and 11. Okay. So this is a engineering plan that shows, in this case, it's water and storm drain. This is called a plan and profile drawing. Okay. So what we have here on the top, we have a bird's eye view, like you're in a helicopter looking down on the road. So that's a top view, and that's called the plan view. And then down below, we make a cut through the ground that shows how that road slopes. So that shows the surface up here, the original ground up there, but it also shows what's happening underground there too. Okay, so that's called the profile view. Okay, so together these are called plan and profile. Now the information we have on here, we have a north arrow. Okay, we always want to know which way north is on these drawings. We've got the road and a little bit of a title. So the road name, this is Link Street. And then a title, we've got the scale, 1 inch to 50 feet. We've also got a lot of numbers on this, I guess you would say. What we have here is a system of measuring a horizontal distance along the road called stationing. Okay, so we're starting at 0 feet. Now, in the old days when they surveyed, they used 100-foot tapes. So they developed this convention of putting a plus sign between the hundreds and tens column on the numbers. So rather than calling that just 0, they call it 0 plus 0, 0. And then we're marking this grid off every 50 feet. So here, for instance, is 1 plus 50. That's 150 feet down the line is what that is. Okay, that means one full tape, which is 100 feet plus 50 feet more. That's the meaning of that. That's why there's a plus sign in there. Okay, and that's used as kind of like a number line that's used to measure the system as you work your way down it. All right. Now for this road here, we've got quite a bit of other information. We've got the basic reference line for the road is called the center line. That's shown with this dashed line. So that center line is running, as you might expect, right down the center of the road. And it's called out with stations. So it starts at 0 plus 0, 0, which is its starting point. We've got some other points marked out here. We've got, we're kind of going 156.7 feet due east there. And then that gets us to 1 plus 56.7. Then we get into a curve because we're changing direction. So we've got a horizontal curve in there, the length of which is 49.78. So that gets us to station 20648. And then we proceed at this direction there called a bearing. That's south 82 degrees, 52 minutes, 13 seconds east, which tells us the direction on a compass. Okay, and that runs us down until we hit this other center line at 328.43 feet down the line. All right, so that's the reference line for the road. Now we've got a number of other lines here too. We've got the lot lines, which are usually the furthest lines out. Not always, but typically they are. So this is the private property that people own. Okay. And I'm showing that, I'm outlining that right now. So on the outside of that, we've got where people's property is. On the inside of these lines here, what we have is called the right-of-way, typically abbreviated ROW. Sometimes just RW, but usually I've seen it ROW, right-of-way. That's the publicly owned land that the city can use to build their road and put their utility pipes in. Their water and sewer and storm drain. Okay, the next line in then is the curb line. Okay, so that's the next one in. This is just the top, typically the inner face of the curb is what's represented with that line. Or that might also, if you don't have curb and gutter, that might be the edge of the road, which would be the edge of the asphalt, which would be the next line in. But here this is curb and gutter, so we've got the inner top face of curb, it's called. Okay. All right, and then you have the center line. Now, there's sometimes on roads you also have something called an easement, which is a line that shows where the private landowners have given the right to someone else to use their land for some specific purpose. So sometimes you'll see that outside the right-of-way line, outside that property line there. That would be a use of that might be for cable TV or something like that. So the private landowners might give up what's called a public utility easement, where the cable TV, electric, private utility easement. The private utilities could get on there and put their stuff in the ground on someone else's property, okay? And that might be some type of easement there. All right, on the top here, we've got, a few other things going on. We've got the width of the road shown. So that's a 34-foot wide road. That would be from inner curb to inner curb. We've got the distance and bearing on the lines shown there, which again, the bearings are like a compass direction. And then the stations. Okay, now down below what we have are the stations and a nice even grid every 50 feet. The grid itself is broken into 25 feet horizontally. It's labeled every 50. Okay, so that runs its way across the page. Then we have the elevations above sea level, typically at a different scale than we use horizontally. We like to exaggerate that vertical scale so we can actually look at these maps and see which way things are sloping. That helps us to understand grades and how water would flow and that sort of thing. So that's on there as well. And then we've got the grades, which is the slope of the line of the road. So I've got center line at 0.01. That's the slope of that part of the road. So that's a 1% grade. Here's center line at 0.0157, so that's a 1.57% grade. Typically, there would be a vertical curve in here too, which is a transition curve from one grade to the next. Okay, down below, what we're doing is we're calling out the elevations above sea level of the points on the road. So that's what those are. This is a set of plans that's intended for construction, so that tells the contractor what the elevation of the road would be at those different stations. Okay, so that's the information about the road. Now we've also, typically on a set of road plans, you'll show the storm drain too, because the road and storm drain are kind of linked together. So on this top view, what we have, just going to clear that out a little bit, is we need some curb inlets right here. Okay, there and there. Okay. Now, those are required because we've got a low point in the road. See, the road reaches its low point at station 2+00. So the water is going to collect there. So we need to get some way to get that water off the road, out of the gutter, I guess I should say. So we put a box in there with a grate on it, and the water will then flow through the gutter into the box. Then we put pipes out of the box that go to a manhole, and then we go to a storm drain main, which runs, in this case, to the left or west, down to another storm drain manhole. And eventually that'll flow into a river or a pond or a lake or a stream or something. Okay, so that's what's being shown here, is this curb inlets flowing into a manhole and then the pipe running out. Here you see the manhole. That scale is very exaggerated, so the manhole looks very thin. And then you see some information about that. So that's a storm drain manhole, station 2+00. It's 4 feet right of the center line. So we got this station and how far right of the center line it is. Then it has a western invert elevation, i.e. means invert elevation, of 372.15 feet above center line. Excuse me, above sea level. Okay, then we've got the information about the pipe here. You can see the pipe's graded, so the water will flow this way. It's 12-inch. ASTM, American Society of Testing Materials, 3034, that's just a designation number. SDR 35 is the wall thickness. PVC is the type of pipe, and then the grade at at 0.0038. It's 195.5 feet long. So the water is going to flow out of that one manhole downhill to the other manhole. And then we've got invert elevations here for the other manhole that are called out. So that's the information so that this can be built. Okay. Now the invert elevation is right there on a pipe. That's what we call the invert elevation, typically abbreviated IE. It's the inside bottom of the pipe. That's the lowest point where the water will be. So that's what we call the invert. Okay, so the water's right down there. That's the lowest point of the water inside the pipe. Okay, so there's the road and storm drain. We also have another drawing that will show the water and sewer. Those are kind of related systems, so they're typically shown in one drawing. You'll notice we use the same base map as before, so we've got the same scaling, same north arrow, all of that. We just turn off some of the information for the road and storm drain and then add this information for water and sewer. So what we have going on here is we have a T intersection. Those bow tie symbols are valves. The little triangle is called a thrust block, which helps absorb kind of water hammer when we create a T like that. And then we have labeled the line with a W. Okay, we've got the distance and bearing on the water line as it works its way across. And then we've got services that extend out from the water line to the meter boxes. So those lines with a box with a W in it, those stand for water services, which go to each of the individual lots. Okay, the city builds them out until or actually a developer would build them out and then give them to the city. So the city is responsible for these water services up until the meter. After that, a plumber comes in and connects in and takes the water to the houses or whatever the buildings are. So this set of plans is showing what the city's responsible for. So up to the water meter there. We've also got a fire hydrant assembly right there. All right, so down below, we've got the information that shows how to build this. It shows the length of the pipe, 8-inch diameter, class 52, which refers to the wall thickness. DIP, in this case, means ductile iron pipe. And then we've got the grade of the pipe. Okay, so that's going to come down here and then come back out. So on both sides, we've got the length, size, class, type of pipe, and grade. We have quite a lot of callouts here, which we'll get to in a little bit more detail later, but this kind of tells how to make these connections with the T. So at 0+12, 12 feet right of center line, we've got an 8-inch all-flange water T. So that the flange is the type of connection. We've got 2 8-inch flange by mechanical joint gate valves, 1 flange by mechanical joint adapter, and a thrust block. And then we give the elevation above sea level. Same thing over here. We've got a similar call out on this side. Then we have a fire hydrant assembly called out at station 1 plus 33.72. We do have some other crossings of pipes that cross over these pipes, so we like to call those out just so when they're doing the construction they know they're there. So that's what's being called out there, some pipe crossings. Okay, we also have the sanitary sewer that's shown here. So what we have for sanitary sewer is a little bit different construction method, but it is a system of pipes and services as the water is, though it's built quite a bit differently. So what we have with the sanitary sewer are manholes here, shown with these circles. So every time we've got an intersection or a change in direction, we've got a manhole. And then we show the pipes running between the manholes, and we show their length and bearing as well. So there's a length and bearing, and here's a length and bearing right there. Okay, and then we've marked that with an SS for sanitary sewer. We then have services that again come off of the main and go to each of the lots so that people with buildings can tie into the city sanitary sewer there. So the lines with the SS are the services coming off the main and going to the lots. Okay, down below we've got this, the pipe shown also. So we have these manholes shown as elongated triangles. We call out where they are. So that sanitary sewer manhole, SSMH, is at 3 plus 16.00, 12 feet left of the center line. We have the different sides of the manhole and the invert elevation of the pipes. So that's the case for all 3 of these manholes. And then we've got the length, size, type of pipe, and grade for labels for each of the pipe runs. So we've got 194.37 feet of 8-inch ASTM 3034, which is just a call out for this type of plastic pipe. SDR 35 is the wall thickness and strength. It's PVC, and the grade of it, or the slope, is 0.004. All right, so that's just a run through a set of plans and what that might look like. You've also got some descriptive stuff in the book that goes over what I was just talking about. So there's a start on these infrastructure systems that you would find in the city.